Way 67 deals with solutions. Remember, solutions consist of two parts, the thing that you're dissolving and the substance that it's being dissolved in. We call the item that's being dissolved the solute, and the item that it's dissolving in, the liquid part, the solvent. And in total, if the solute dissolves into the solvent, we would say that it is soluble, and that solution is aqueous. Remember, that is a mixture. The solute and solvent are not chemically bonded. They're merely dissolved into each other. If the solute is not capable of being dissolved in the solution or the solvent, we would say that it's insoluble. And we indicate that by a solid in parentheses. So if a substance is soluble, it's aqueous. If a substance is insoluble, it would be solid, what's called a precipitate. And remember, the word aqueous simply means that it's dissolved in water. So the solute was able to successfully dissolve in water, we would say that it's aqueous. So how do we know if a substance is dissolvable in water? Well, we rely on table F. Note that table F lists two different charts. This tells you the ions that form soluble compounds with their exceptions. These tell you the ions that always form insoluble compounds, meaning that they have very poor solubility in H2O and will form solid compounds, with the exceptions. Now, please note the word exceptions in this case. These ions always form soluble compounds unless mixed with these exceptions. So, for example, lithium, when we mix it with anything, is going to form a soluble compound. Chlorine will always form soluble compounds, except when it's mixed with any one of these ions. So silver chloride will be insoluble because it is an exception to the rule. When it comes to the other chart, these always form insoluble compounds, except when mixed with certain items. So carbonate will always be insoluble, meaning it forms a solid precipitate, except when it's mixed with group 1. So anything from group 1 with carbonate will be soluble. So for example, lithium carbonate, sodium carbonate, potassium carbonate, all of those are soluble, except it's an exception to this rule because it's mixed with group 1. Likewise, ammonium carbonate would also be soluble because it's an exception to this rule. So once again, all these form insoluble compounds except when mixed with these. These are always soluble except when mixed with these. So we're going to use this information to answer some questions. According to table F, which substance is most soluble in water? Here we're looking for a substance that is soluble in water. So we may need to consult either chart in order to do this information. Notice silver chloride. Chloride is always soluble except when mixed with silver. So this is insoluble. Carbonate is insoluble as well because it is not an exception to this rule. Calcium is in group 2. When we look at sodium carbonate, however, notice that carbonate is always insoluble except when mixed with group 1. Sodium is a group 1 element. Therefore, choice 3 is soluble in water. Look at strontium sulfate. Sulfate is soluble except when it's mixed with strontium. So this is an insoluble compound. Thus, choice 3 is correct because it is the only substance soluble in water. Based on table F, which compound is least soluble in water? So again, here's table F. This problem says that based on table F, which compound is least soluble in water? So look at the chart and figure out which one of these compounds should be least soluble. Looking up the first one, phosphate, we see that it is always insoluble except mixed with group 1 and NH4. So this is not an exception. This should be insoluble. Lithium sulfate always forms soluble compounds. Calcium hydroxide, look up hydroxide, and we see that it is one of the exceptions to this insoluble rule. So choice 3 is also soluble. And choice 4, silver acetate. Acetate always forms soluble compounds no matter what it's mixed with. There are no exceptions, so choice 1 is correct. Aluminum phosphate. It always forms insoluble compounds. Which substance is most soluble in water? Again, here's the chart. Which one of these substances is most soluble? You can verify that ammonium phosphate, when phosphate is mixed with ammonium, it is a soluble compound because it's an exception. Phosphate normally forms insoluble compounds except when it's mixed with ammonium. Therefore, number 1 is the most soluble. Which compound is soluble in water? Again, here's the chart. Figure out which compound is the most soluble. You should note that sodium always forms soluble compounds no matter what it's mixed with. There are no exceptions, so choice 3 is correct because it is the most soluble. All these compounds you'll verify are insoluble. For example, lead sulfide. Here we have, where is it? Lead sulfide. Oh, sulfide. Sorry, lead sulfide is not an exception to this rule. Therefore, lead sulfide is an insoluble compound. Sulfide always forms insoluble compounds. Which compound is insoluble in water? To locate the compound that's insoluble, locate sulfate, which is here, and we notice that sulfate is always soluble unless mixed with lead. And here we have lead 2 sulfate, and it's an exception to this rule. So lead 2 sulfate should be an insoluble compound. You can verify that choice 1, 2, and 3 are all soluble. For example, potassium hydroxide. Potassium is in group 1. When we mix group 1 with any item, it's always soluble. Based on table F, which equation represents a saturated solution having the lowest concentration of chloride ions? Now notice that all of these substances are being dissolved in water. So we're looking for the one with the lowest concentration of chloride ions. The one with the lowest concentration is the one that prefers to be solid and not the right side, which indicates that the substance is dissolving. So which one of these substances is least likely to dissolve into ions? You should note that every one of these substances forms soluble compounds except for choice 2. So silver chloride, when it's dissolved in water, actually prefers to stay a solid because it's very insoluble in water. Thus, it's not going to be producing many chloride ions in solution. Sodium is one of those things that form soluble compounds and will always dissolve. Therefore, it will happily form chloride ions. Same thing with ammonium chloride. So the one that's going to have the lowest concentration of dissolved chloride ions is the one that's going to remain insoluble. So choice 2 is correct. So when it comes to table F, please note that the first chart always forms soluble compounds with the following exceptions, and the second chart indicates insoluble compounds with the following exceptions. You need to be comfortable reading this chart in order to decide whether something is soluble or insoluble. Occasionally, they'll ask you which of the following saturated solutions produces the lowest concentration. In that case, if it's the lowest concentration of ions, it's going to be the least soluble. Hopefully this was helpful, and thank you for watching.